All right, day 4, reInvent. Let's go. We made it. We really appreciate you spending the week with us. Hope you've had a blast. So if you're here or if you're listening, we're assuming you're fairly comfortable and familiar with security services, network security principles, and you're looking to unpack some best practices, learn some key takeaways to get you started and on a journey towards zero trust and least privilege from an egress controls perspective. My name is Sofia Aluma, and I'm a security specialist in our security organization. I'm joined here by my colleague, Michael Leidy. He's a security solution architect, and he'll do a longer introduction in his portion of the agenda. So we've got a jam-packed session for you today. We'll start with some customer journey, kind of what we're hearing in the industry, what we're hearing, pain points and challenges, observations, et cetera. We'll level set on some kind of foundational terminology. This is a 300-level session, but we just want to make sure that from a terminology perspective, we're all on the same page. We'll also touch on some of our security services that are relevant in terms of an egress controls and network security discussion. And then I'll hand it off to Michael, who will do kind of unpack the meat and potatoes of the talk. He'll really walk us through a ransomware pattern from an egress perspective and how these services work in conjunction to really provide a robust egress control strategy. We'll walk through some best practices and key takeaways, cover what's new, and then wrap it up. So what are we hearing from customers? Network and security and cloud security teams have to balance a number of competing priorities when they're laying out their network security strategy. Folks have to stay on top of an ever-evolving threat landscape, especially from a network security perspective, how to manage egress controls to prevent for a potential risk of data exfiltration. Compliance is also a big piece. If you handle any sort of sensitive data, which could be customer or, let's face it, IP-related data, you'll want to make sure you're up to date with the latest and greatest of frameworks, regulations, and data sovereignty, potential geofencing, et cetera. And it's not only staying compliant, but making sure you're able to report and prove this compliance on a regular basis. Teams also have to manage a varying degree of complexity in terms of their estate, be it merger and acquisition, dealing with subsidiaries, franchises, maybe maintaining internal solutions, third-party applications, multi-hybrid cloud environments. So a reliance and a need for solutions that are highly scalable, reliant, and ease of use become extremely important. So just to level set, when, in case you haven't heard or the word egress kind of trips you up, at the basic level, we just want you to think that's traffic that may be that is initiating inside of your network at the VPC level that's looking to call out and exit your network. And we'll walk through this in detail, but it's also important to remember that there's 2 paths out to the internet, the traditional kind of network IP path, but there's also the DNS. That's important to remember. Research shows that DNS is actually a massively overlooked attack surface. Research out of Palo Alto is finding that 85% of malware abuses DNS for its malicious activity. And IDC found that 88% of organizations, when surveyed, experienced a DNS attack in the last year alone. So in terms of these vulnerabilities, in terms of these risks, we want you to take a look at Amazon Route 53 Resolver DNS Firewall from the DNS perspective. It's a mouthful, but at its basic level, think it's a firewall for that DNS traffic. It's a highly robust, easy to deploy managed service. And some of its more newer features include the support of Route 53 profiles for central configuration of profiles, domain redirection, and a feature that we just launched a couple of weeks ago, which allows you to block and monitor against more of these advanced DNS threats, like DNS tunneling, for example. Also in scope for today is AWS Network Firewall. This allows you to deploy essential network protections for your VPCs. Again, highly robust, highly configurable, customizable, supports deep packet inspection and some more advanced inspection capabilities like TLS inspection. And together with DNS Firewall, they provide a really robust strategy against some of these egress vulnerabilities. So you may be asking, why? Why is egress important? Why should I care, Sophia? So if you're in the security space or security adjacent, chances are you've probably heard of this term, but humor me. Let's walk back to December 2021 when this was still an unknown zero-day exploit. So let's say we're in a cloud security team. We've just wrapped up an awesome year of deployments towards our, to protect our environments against maybe some known web application exploits, et cetera. On that ingress path, we're feeling really great. Maybe our traffic doesn't call out too much to the internet, so from an egress perspective, the prioritization just maybe hasn't happened yet. Suddenly, phone notifications popping up, it looks like the world's going to explode. We're hearing about this vulnerability that's just been discovered that's leveraging an open sourced logging framework from Apache known as Log4j. Now we have to see, is this relevant to us? Does this impact us? The key thing about the Log4j vulnerability was that it had to call out to another server to then download a malicious exploit. This is where egress controls come in. If we have these egress controls in place, we would be protected from that front. Now you might be saying, that's cool, Sophia. Don't you know they patched it? That was 3-4 years ago. Why is it still relevant now? We're seeing that the daily downloads of this unpatched software of the old version of the Log4j can hit daily downloads of up to 30%. So, and it's not just Log4j. This concept is known as software supply chain security risks, where from an application building perspective, we build on open source tools and rely on teams of other maintainers that we may not know or have control over, like the XZ utils backdoor. This was a really slow burn, sophisticated social engineering where the maintainer earned the trust of the team and then inserted malicious code. So as cloud security teams, we have to stay on top of all of these threats and vulnerabilities. But what if it was easier? What if there was an easier way to lay out your strategy to reduce your risk? And this is what we really want to dig into today, helping you build toward a more zero trust, least privilege strategy where you're building towards an explicit allow and implicit deny strategy. With that, I'll hand it off to my colleague Michael, who will walk us through this.
Thank you, Sophia. Sophia said I'm a AWS Senior Security SA here at AWS. I've been here a little over 3 years now, and my background's in network security. A little over 10 years doing that. I've worked at companies such as Infoblox, which does DNS security, and Palo Alto Networks. And here at AWS, I really focus my time a lot on helping some of our larger customers adopt some of these services that we're going to talk about today. And then I try and take what I learned from those interactions and go to the service teams and make these services better. Before I get started today, I really want to dive into some mental models for how we do network security. And I know that's not something we typically talk about in the sort of day-to-day of doing security, but I do think, given the nature of events like this, it's a great opportunity for us to step back and look at these sort of metaphors we use to both perceive and respond to threats. So imagine for a moment that this castle is your cloud environment. It's very heavily fortified, it's guarded, it's got many layers of controls. You have the biggest, baddest, most sophisticated set of ingress controls that keep out the bad guys on the internet. Now, this tends to be the mental model that I see from most folks out there, and it's absolutely warranted because we know the internet is a crazy place. There's new threats that are popping up there all the time. It does tend to sort of push us towards a mental model where we really try and focus on building this sort of invulnerable fortress, and we can over-rotate on some of those ingress controls, thinking we're going to keep all the bad things out. And the big thing that this causes us sometimes to miss in terms of our mental models is that our digital resources in the cloud aren't really static treasures that are locked in a vault somewhere. These workloads, our applications, et cetera, they're all very active participants in a dynamic ecosystem. And really what controls their behavior underneath the hood is largely code. Now, some of this code gets written by your developers, but a much larger percentage, the sort of below the waterline in the iceberg analogy, it's all code that's written by other folks, right? So this is operating systems, it's third-party libraries, it's all kinds of packages that become the building blocks for what your developers actually build into your applications and services. And so in this analogy, we know that with this huge crawling attack surface, that vulnerabilities actually are just a part of the equation. There's never going to be this invulnerable fortress model. Sophia mentioned the Log4j vulnerability. That's an example of one that we know about and we can still go and patch. But then there's all the 0 days out there that we've yet to discover. So the Log4js of the future. And then as Sophia also alluded to, there's a sort of worrying trend that we're seeing where threat actors will infiltrate open source ecosystems to put malicious code into very common dependencies. So in a situation where we had invested all of our time and energy on just the ingress side of the equation, those compromised workloads could then just go out to the internet, access malicious destinations, exfiltrate data, et cetera, without anything to inspect. So at the end of the day, yes, prioritize ingress because the internet's a bad place, but don't forget to reserve some of your time, effort, energy, engineering effort for putting in egress controls. Okay, so to kind of explain how networking works in the Amazon PPC, I'm going to first look at the ingress side of the equation, and then we'll flip the script, and from this same web application architecture, we'll look at the flip side, which is the egress side of the story. So this is a very simple web application architecture. We have our public subnet, or our application load balancer that sits in a public subnet, and it has workloads that are out in a private subnet. It's going to forward the traffic from that application from our end users out on the internet. It's going to hit the application load balancer. It forwards the traffic back to those workloads on the back end. Those workloads could be EC2 instances, they could be EKS containers, or even some sort of serverless architecture. It doesn't really matter for the purposes of this conversation. Now, from a network security perspective, the first thing we want to talk about is something called security groups. It's a great virtual firewall. It's built into the fabric of the VPC. It's going to limit what particular protocols are allowed to come into that application load balancer. So in this case, let's say it's encrypted HTTP communications. So we'd have port TCP 443 that's allowed in and nothing else. And that restricts that access. And then on top of that, given the fact that this is a web application, you'd want something that actually inspects web application traffic, which would be a web application firewall. So this could be something like AWS WAF, it could be a partner WAF, et cetera. This is going to give me the ability to look deeper into web-specific threats. So that's things like SQL injection or cross-site scripting or even DDoS attacks. Now, the reason I bring up all this is because wherever you have these type of ingress controls in your environment today, this is a really good place to think about where should I begin my egress journey. Probably these workloads are going to have access to sensitive customer data or internal intellectual property. And so it's a great place where we should prioritize what those workloads are able to access on the internet. Okay, so now let's talk about the other side of the equation, the egress side. And it all begins with DNS. If you've been in networking for a while, you've probably heard this phrase, it's always DNS. And what that reflects is the fact that DNS is the foundational critical protocol that runs the internet. So 99.999% of all your critical network flows will begin their life with a DNS lookup. So if DNS is down, your network's effectively down. So to deal with this, the Amazon VPC has this very cool feature. It's called the Route 53 resolver. Some people call it the .2 listener because it's at that .2 address. And it creates this always-on, amazingly reliable DNS resolution service. So let's say my workloads need to talk to some S3 endpoint. They're going to talk to that Route 53 resolver to look up the endpoint. It's going to go via a service managed plane to the internet and talk to the authoritative DNS servers that house the IP address for that domain. Now, one thing to point out here that's not often considered, but DNS by its very nature is a two-way communication channel going to the internet. You have a question, you have a response back. That whole thing is effectively two-way communication. And if you think about it, that has security implications, and we'll talk about that in a little bit more detail here. So in this case, we resolved the IP of an S3 endpoint for our bucket, and now we're going to go out the door to communicate with it. So the next problem we have is these are private subnets, and so that workload doesn't have an IP address of its own on the public internet. So we have what's called a NAT gateway or some other NAT device. It's going to share its IP address and allow that communication out to the internet. So at the end of the day, we have these two routes out to the internet. We have the traditional IP route through that NAT gateway, and then we have the DNS route, which are both channels to the internet that we want to consider when we think about egress controls. So now we're going to pivot and look at how would a threat actor make use of these same egress connections. And again, while we're thinking about this, I don't want us to think, oh no, look what the bad guys can do. Look how innovative they are. Really, the takeaway should be threat actors always have to do lots of different steps to achieve their goals. And so as we walk through those different steps, think about the ways in which we could block those with the tools we'll talk about. So to illustrate this, I'm going to talk about a real-world example of a malware called Melify. It happens to target Linux servers, and this malware begins its life cycle with a wget request, or actually a series of them, that go direct to IP. So they don't actually use any DNS. They're going straight to a hard-coded IP address, and they go out over a somewhat unusual port. For HTTP, it's unencrypted HTTP, but it's over 8765. Now, we often do see this sort of unusual activity in terms of unusual ports for hosting malware. The reason being that threat actors often host their malware and other tools on compromised systems. So on that compromised system, they may not have access to the lower ports. If they don't have root access, they also may be trying to host this on a web server that already is using those ports. So oftentimes we will see sort of unusual ports used. So in this case, we have the two wget requests. They come in back and download both a rootkit and an implant on the workload. The implant maintains its persistence there by inserting itself into some RC local scripts. And the rootkit is a kernel module that will insert itself into RC modules. Once that implant is running, it wants to talk back to its C2 infrastructure. And to do that, it's going to resolve the IP address that's associated with that C2 domain. It's almost always the case that we see attackers will use DNS for that C2 infrastructure. And the reason being is it just increases the flexibility and availability of that service. So the same reason we don't use hard-coded IP addresses with our applications is the same reason attackers do it, because it increases the availability, the reliability of that C2 infrastructure. It gives them a lot more options. So we resolve the IP address associated with the C2 domain for the malware, and then it's going to go out the door through our NAT gateway. And once it gets to that threat actor's C2 infrastructure, this is really the point where we have full compromise. At this point, the hands on keyboard, whoever's controlling the infrastructure, can now control what that rootkit and implant back on our compromised workload are able to do. And really what happens next could vary quite a bit, right? So the attacker's goals could involve moving laterally in the environment. They may install additional tools to help maintain their persistence over time. There's quite a number of things that they might do. They could exfiltrate or encrypt sensitive data, as in the case with ransomware, which is pretty commonly in the news because it tends to be a big event when that happens. The other thing they'll do is they'll try and find additional AWS credentials or SSH keys that help them maintain their and grant further access. But again, the big takeaway was we saw how these egress steps worked. These were all things that we could potentially block with either DNS firewall or network firewall or some combination of the two of them working together. So many opportunities. We don't have to block every single step. We've just blocked one of those steps. Effectively, the threat actor never reached full compromise. So now I'm going to talk about how we can make our own journey towards least privilege. And hopefully, if you've been listening closely to everything I've been saying so far, none of this will be too shocking. So at a bare minimum, what we want to do is block known bad. And one of the ways we can do this that's rather simple and direct is we can leverage AWS managed threat roles that are built into those services we've discussed. So these threat roles give us capabilities to block known bad destinations on the internet. Both services support rules that can be put into both an alert mode first and then into a block. And then this threat intel is coming from both internal AWS sources as well as external partner data. And for network firewall as well, it includes not only what we would think of as malicious domain names, but it also looks at other kind of wider characteristics of network traffic. So it can see, for instance, threat signatures related to things like coin mining, and other characteristics of malware C2 traffic. After we've blocked known bad, the next thing we would like to do is block risky locations as much as possible. So one way you could do this is, this is just one of many, but there's, for your environments, you may just know there's certain parts of the internet you don't need to communicate with, so you just take that risk off the table by blocking them. So one way to do this is there's a lot of top-level domains that we know are just commonly abused. So top-level domain, or TLD, that's the sort of suffix ending of the .com, .edu, et cetera. And there's a whole bunch of them out there that are just very poorly policed, and there's just a whole crop of new malware domains that is coming up on them every day. And there's not a lot of legit traffic that needs to go there. So if you want to dive into this further, you can go out there and look. There's tons of statistical analysis about which ones are kind of the worst offenders in this regard. And most of the customers we talk to, they don't have legitimate reasons for their workloads need to communicate there. Also, network firewall has a new geographic-based IP filtering capability. So you can say, for instance, there's certain countries I just don't want to send traffic to, or I know my customers are going to be in these locations, or the partner I'm communicating with here is only going to be in these locations, so you can filter based on that. And I'll talk about that a little bit more in a subsequent slide. Next, what we want to do is validate which protocols we're allowing to go to the internet. So built into it, network firewall has a very advanced capabilities to do deep packet inspection. And it can natively identify over 20 different protocols just out of the box. And what this allows it to do is give you both logging and filtering capabilities on key metadata that's in those protocols. And so, for instance, that example we showed earlier where HTTP was going over an unusual port. easily detected and blocked. Or that direct IP component of the wget request. We could detect and block that very easily as well. I mentioned it already has 20 different protocols. They're adding to that all the time. We just added recently HTTP2, Quick, and PostgreSQL. And it's definitely something when talking to customers, we're always looking to hear, like, what is the top thing that you have that's not on the list today? So, if you have any feedback about that, please come see me. And then last but not least is to allow only egress to trusted domains. So we hear from customers a lot that this is challenging, but we still see that many, many customers are starting their journey towards this. And when you think about it, at the end of the day, what your workloads are doing in your cloud environment should be very unlike what typical user traffic is, which is going to very broad and changing destinations on a daily basis. Your workloads should have a fairly circumscribed, limited set of destinations that they need to talk to. And so the way customers will kind of start their journey down this path is what they'll do is they'll create a firewall policy. It has a list of what those top domains that they know that they trust and they need to access. And then they'll just alert on anything else that is not matching those top trusted domains. And then slowly over time, what they do is they just investigate what domains are coming up from that alerted traffic until they get confidence that they fully mapped out the actual domains that their traffic needs, that their workloads need to communicate with. Once they've done this, they change that final action to block, and now they're in a mode where if you're not on our allow list, you're not allowed to the internet. And again, this allows for very substantial risk mitigation. You no longer have to have an up-to-the-minute, threat intel list of every bad thing happening on the internet because you're blocking access to most of it. And this is such a popular sort of use case with the firewall that the service team is making a lot of active investments at this time to kind of streamline and reduce friction here. And we're going to talk a little bit about some other new features here on the next slide. So I already mentioned geographic IP filtering, so I'll just double click on this a little bit. This was actually one of our most requested features in terms of what we call PFRs. And it launched in August of this year. And again, simply put, it just gives me capabilities now within the firewall to control what countries I'm either allowing communication to or from in my Amazon VPC. And so, for instance, we talk to a lot of customers and they say, I know my workloads are all going to be communicating with these countries, so it's very easy to just create an allow list model for those, or I can block access to specific countries. Probably the most common thing we always hear from customers, especially here in the US, is customers who want to block countries that are on what's called the International Traffic in Arms sanction list. It's called ITAR for short. But there's compliance reasons why a lot of customers are required to block that traffic. But they also get really substantial risk mitigation as well when you're blocking, regions of the world where we know that there's just less likely that a threat actor is going to get held to account if they do something wrong. And we also see a lot of state sponsorship of malicious activities coming from the same locations. And then also DNS Firewall Advanced, which, as the name suggests, it's an advanced capability. This just came out about a week and a half ago, actually, and it gives capabilities for blocking DNS tunneling. I didn't really dive into that as much as I meant to in the talk, but this is something that is actively used by many C2 tools out there. Probably most notoriously, it's used by something like Cobalt Strike, Sliver, other C2 tools, which we know get used in ransomware attacks. And what it does is it allows them to bypass traditional controls for that are typically looking at this. So with this feature, you can now detect this and block it in real time. If you have guard duty actually can do some detection of this, but it's delayed and it's not in line, so it can't block it. So with this, you actually can block this activity. The other thing that DNS Firewall Advanced can block is something called domain generation algorithms, or DGAs for short. A domain generation algorithm is an algorithm that gets built into malware and essentially gives it lots and lots and lots of C2 domains that it can communicate with. So the thinking is that as my C2 domains get identified, they go into block lists, they get taken down by authorities, that malware still has thousands, hundreds of thousands of domains that it can cycle through to communicate with over its life. And so it's very, very, very difficult with a static block measure to detect and block that. So DNS Firewall Advanced has basically machine learning capabilities to identify these in real time and block them. And I actually have a workshop that I just built. I just ran it, so fortunately you can't run it here at reInvent, but if you're interested in playing with this feature and detecting and blocking DNS tunneling and those sorts of events, come see me after. And now I'm going to hand it back to Sophia.
Awesome. Thanks, Michael. Well, this about wraps us up. We hope we've covered these 4 key principles to get you started on that journey towards least privilege. If you want to dig into and get started on some of these, we really recommend you bookmarking some of these resources, especially the top one up here, the Network Firewall Best Practices. This is really a great guide, examples, scenarios, FAQs, etc., troubleshooting that Michael here and a colleague, Jesse Lepich, have built out. Also, as Michael mentioned, if you want to get hands-on with some of the principles we covered today, and especially play around with some of the new DNS Firewall Advanced capabilities, encourage you to check out this workshop that you can, if you're interested in getting access to it, let us know. We really appreciate your time. If you have any questions, we'll stick around for a few minutes. But other than that, let us know how we did, and hope to see you next year. Thanks.